Hello everyone, I am Dipanita, your TA. Welcome to the sixth interaction session of NOC113, Fundamentals of Electrical Engineering. This week you have been taught about inductors and capacitors and how to solve a few of the problems using either like circuit theorem and the properties of inductor and capacitor. So today we will be following up a few problems regarding the same. So the first problem is given here. It is given that in this particular circuit, this is a switch, and at t time equal to 0, the switch position is changed from A to B. So given this condition, we have to find what is di by dt at time t equal to just after 0, that is 0 plus. So a few of the things that needs to be remembered is that in an inductor, like current across an inductor does not change instantaneously. That is, any inductor opposes the change of current. And in case of capacitor, the voltage across this capacitor cannot change abruptly. Okay, these two things you need to remember for inductor and capacitor. And a few more pointers is that under steady state condition, that is, for example, in this circuit, when this particular switch is at A and it has been flowing for a long duration of time, so under steady state, for this, since this is a DC voltage, under steady state condition, the capacitor will behave as open circuit. That is, capacitor will be acting as an open circuit with a voltage Vc. Whereas inductor under steady state, for a DC source, when it is connected towards a DC source, it acts as a short circuit. So a current will be flowing and it will act as a short circuit. These are the few things you need to know before solving any other problem. So for this particular problem, how we will solve? So it is given that initially the switch was in A position. So at time equal to minus infinity up to 0, the circuit was something like this. So this capacitor was not joined, like it was not connected to the circuit, it was just there. So this is a 1 kilo ohm resistance, 1 Henry is the inductance, and voltage is 100 volt. So from time t equal to infinity to 0, up to 0, this was the circuit. So basically it has attained like a kind of steady state from minus infinity to 0 time. So basically this inductor, it acts as a short circuit.
Okay.
Let me just admit. Huh. So since this inductor is acting as a short circuit, the current that will be flowing through this particular circuit will be, current will be just V by the R, V by R, that is 1, since it is in kilo ohm, 10 to the power 3.
0.1 ampere.
Right, 0.1 ampere. Now as soon as at time t equal to 0, the switch has been switched from A to position B. Now what is happening is the circuit kind of looks like this. So this is A, this is B. So this is the capacitor. Now the circuit kind of look like this. This 100 volt source is not connected to this particular circuit. This is 1 kilo ohm, this is zero point 0.1 microfarad, and this is 1 Henry. Now see, like a current of 0.1 ampere was flowing through this particular inductance, right? and inductance will not oppose, will oppose the change of current. As soon as this voltage supply source has been disconnected from this particular circuit, inductance will try not to change this current. So at an instant t equal to 0 plus, that means it is 0 plus some delta t, which is very small. So at this particular instant, this change of current across this inductor will not take place, and hence this current will try to flow through the circuit. So under that condition, the equation that in this particular loop will be given by, so if we just assume that I of t current is flowing, let me use a different color. So let us assume that I of t current is flowing in this circuit. So it will be R into I of t plus L di by dt plus 1 by C integration I dt, right? This is the equation. Now at this particular time t equal to 0 plus, initially this voltage source was not, this capacitance was not connected to anything. So it was just sitting idle. As soon as this got connected, there will be this is just the instant when it got connected, right? So there will be actually no initially no current flowing through this. Only the current is coming from here and flowing through this inductance. It will it will start to flow gradually, and this capacitor will get charged. But until then, this plus is just the instant right after switching. So there will be nothing flowing through here. So R we can replace 10 to the power 3. 1 kilo ohm is 10 to the power 3 ohm. This is now we are considering at t equal to 0 plus condition. So this is 0 plus L is 1 Henry di of 0 plus by dt. Here this 0 plus just at that instant there is nothing flowing through it, so this will be equal to 0. So like at that instant of switching, we can find now I of 0. What will be this I of 0? Initially 0.1 ampere current was flowing through this inductor. So this is I equal to, just let's say before switching, that is 0 minus. This will as inductor opposes the change of current, this will also be equal to 0 plus current I at 0 plus condition. So I of 0 plus will also be 0.1 ampere. So 10 to the power 3 into 0.1. This is equal to, if we take it on the other side, minus di of 0 minus by dt. So if we simply write, I'm writing it at the top. So it is di of 0 plus dt will be equal to, negative sign you take it there. So 0.1 into 10 to the power minus 3 is 100. So it is 100 ampere per second. So the correct option will be option B. Is this clear to you? Is it clear to everyone, or do you have any question? Because then, yeah, is it fine?
Yes, ma'am.
Okay, so the next part of the question is a continuation of this. So we will move to the next question. In the next question, you see, it is the similar circuit, and the conditions are all similar. Only now what you were asked is to find di square by dt square at t equal to 0 plus, that is at just the instant of switching, just at the instant after switching. So we'll just draw the circuit. This is B. So now the circuit is in this condition. the capacitor has just started to you know just started charging. So now similarly, if this was I of t in this using KVL, we have R I of t, the same equation we have here, this particular equation, plus L di by dt plus 1 by c integration I dt is equal to 0. Now to this equation we differentiate it, that is d dt of 1. What will be R I of di by dt. Why we are differentiating? Because we need this double differentiative term, right? So L di square by dt square plus this will be I of t by c equal to 0. Now we plug in all the values. It is 1 kilo ohm. So now let us replace this equation for t equal to 0 plus just after instant of switching. So this is equal to 1 kilo ohm into di by dt we have found in the previous problem, right? See, di by dt at 0 plus. So right now let us just write the equation. Di at 0 plus by dt plus L is 1 di d square I of 0 plus dt square plus I of 0 plus by c is 0.1 into 10 to the power minus 6 equal to 0. So 1000 into di by dt we have found it is minus 100, right, in the previous problem. This is d square I by dt square 0 plus I of 0 we have calculated, like initially when the position was in switch A. This is I of 0, this is I of 0, right? So we have 0.1 by 0.1 into 10 to the power minus 6. So if we write it here, so it is minus 10 to the power 5 plus di d square I d dt square plus, if you this is 1 by 10 to the power minus 6, right? If we bring it on the top, it is 10 to the power plus 6 will be equal to 0. Now you can easily calculate what is di2 by dt square. It will be equal to 10 to the power 5 minus 10 to the power 6. Just take 10 to the power 5 common, 1 minus 10, it is minus 9 into 10 to the power 5 ampere per second square. So the correct option will be option C. Clear to everyone? Anyone has any queries?
No, ma'am.
Okay.
Okay.
Then we'll move to the next question. So now that you're like familiar with how to do this problem, let's try this one. So the circuit as shown here is in steady state with this particular switch is closed. Now the switch is open at t equal to 0. You have to determine dv by dt at the instant just after switching. So initially, how will the circuit look like? So the remember the word steady state. At steady state, what happens to the capacitor?
Circuit. Open circuit.
Right. And inductor is short circuited, right?
Short
So
circuit.
the current that is actually flowing through this inductor will be just, let us say, I of 0 minus just before switching. So it is V by R. R here is 1 ohm. So it is 2 ampere. So this I of 0 minus will be I of 0 plus, because inductor will oppose any change in current. So this will be 2 ampere only, right? Now let this like voltage across the this Vs is the given as voltage across the capacitor, right? Capacitor will oppose any change in voltage. So Vs of 0 minus, since look, this particular switch, it is a switch, that is, it is just a short circuit. So Vs minus is equal to 0, and since capacitor will oppose any change in voltage, so 0 plus Vs 0 plus will also be equal to 0, right? Now when the switch is opened, that is, now the circuit kind of look like this. So this is the circuit now looking like. So now if you just apply KVL across this particular loop, it will be, since the source is 2 volt, it is equal to, so what you can also do is, like, the current that is flowing now uh, across through this like capacitor, I you know, uh, Vc is in 1 by c integration I of t, so I will be equal to c dvs by dt, right? So this I of 0 plus, which is equal to 2 ampere, this I of 0 plus is actually equal to c dv of 0 plus by dt. Okay, now uh, let us just look like at this particular point, let like at t equal to 0, 0 plus, just at the instant after switching, this inductor, like initially at steady state it is as short circuit, right? Now just after switching, what will happen is the inductor will just behave as a open circuit, right? So it will be 2 equal to V of t by 10. Sorry, you don't really need that. Sorry. What you need is Vs by dt at time t equal to 0, right? So you already have it. So from this equation, you can find out dVs of 0 plus by dt, which will be equal to I of 0 plus by C. So I of 0 plus we have already found out as to be 2 ampere, and C here is 0.5 farad. So it is 20 by 5 equal to 4 volt per second, since it is dV by dt. So the correct option will be option A. Is it clear?
Yes, ma'am.
Okay. This was pretty much straightforward. So we'll move to the next question. Now again another circuit in which initially this switch was closed, then at time t equal to 0 the switch was opened. You have to find d square v by dt square, like at just right after the instant the switch was closed. So how will we do that? It is given the voltage across this particular inductor is V of t. Now since this resistor is also in parallel, this will be also V of t, and 2 ampere current is flowing in this branch. Initially, the switch was closed, so as soon as the switch was open, the circuit at time t equal to 0, it will look somewhat like this. So yeah, so this 2 ampere current is flowing from this current source to this branch. Now the voltage across this capacitor is across this inductor is given V of t. So this is basically the node voltage at this particular point. So we can apply KCL in this particular circuit, right? So using KCL, that is current going in is equal to current going out. If current I1 and I2 are flowing, so I1 plus I2 will be equal to 2, right? So what is I1? Voltage by resistance. Resistance is given 10 ohm. So this is 10. What is I2? It is for an inductor, current is equal to 1 by L integration V dot dt, right? So 1 by L is 1 by 0.5 integration V of t dt is equal to 0. But what do you have to find out is d square V by dt square. So what can we do? Sorry, this will be equal to 2 because I1 plus I2 equal to 2. Now since we need d square V by dt square, we need to differentiate this particular equation, right? Because we will get only V of t here. So taking a derivative, dV of t by dt square by dt, 1 by 10 will remain. This will be V of t into 0.5 equal to 2. Sorry, ddd and d, if we differentiate this constant, then it will be equal to 0. Now for calculating dv square, we have to differentiate once again. So here we have differentiated once. Again, if we differentiate, what we will get? 1 by 10 d square v of t dt square plus dv of t by dt equal to 0. Now if you are to obtain this, what do we need to have? This particular value dv of t dt. For that, what do we need? Only v of t. So first let us calculate one by one. So calculating v of t at t equal to 0 plus, right? So at time t equal to 0 plus, initially, since under the steady state a current was flowing like this, but just after switching, the inductor this inductor uh, has not been initially connected to this current source, so this was as an open circuit itself because no current was flowing through it. But just after connecting, it will resist the flow of current, so it will still behave as a open circuit just after switching. So this V of 0, that is at time t equal to 0, V of 0 plus will be this voltage. So node voltage is V of t, right? So at time t equal to 0, whatever the voltage that is supposed to be here should also appear here. So as the inductor opposes any change of current, this entire current will start flowing through this resistance. So the V of t will be I into R, which is this resistance. So here current I is 2 ampere, resistance is 10 ohm, so it will be equal to 20 volt. So at time just after switching, the voltage V0 plus will be equal to 20 volt. So let us say this is equation 1, this is equation 2. So equation 1 can be written as 1 by 10 dV. We are writing it at time equal to 0 plus. Okay, so this will be V of 0 plus by 0.5 equal to 0. Now instead of like V equal to 0 plus, we will put its value because we already have it. So let us put 20 volt equal to 0. So dV of 0 plus by dt will be equal to minus 200 by 5, and this is 1 by 10. So 40. So dV0 plus by dt comes out to be minus 400, right? Now we plug this in equation 2. When we put it in equation 2, it is 1 by 10 d square V 0 plus by dt square plus 1 by 0.5 into this is minus 400 is equal to 0. So if we just rearrange it, I'll just write it here. So d square V of 0 plus by dt square comes out to be, if we take it on the other side, it is here it is 1 by 10, it is 4000 divided by 5. So this is 800. So if we take this 10 in this side, it becomes 8000, but it is plus. So the correct option is 8000 volt per second square. Everyone got it? Is it okay with everyone? You're following, right? If we don't have any doubts, we can move to the next question. So let me see. Okay. Now for this particular question, it is given in this particular circuit, S is closed at time t equal to 0. The rate of change of current di by dt at time t equal to 0 plus is given by which of the option? So since we have done similar problem like this, can you like start solving this? So at time t equal to 0 minus, that is just like before the closing of the switch, how was the circuit? Just a current source connected across a resistor, because this switch was open, right? So the rest of the circuit was not connected. So the current through this inductor at time t equal to 0 minus was 0. No current was flowing through this particular inductor. Now as soon as this switch is closed, this inductor will oppose the flow of any current. So it will behave as if it is an open circuit and no current will flow. So at time equal to 0 plus, the current through the inductor will initially be 0, right? Now for time equal to 0 plus, since the switch is closed, so now the circuit will look like this. So this is closed, this is the inductor. Now it is given I the current flowing in this circuit is I of t. This is 2 ohm, this is resistance R, this is inductance L, and this is 3 ampere given. Now if you consider this particular 2 ohm resistor, what can you observe? So 3 ampere will come like this. It should ideally get distributed between these two branches, but at time t equal to 0 plus, inductor will oppose the change of current flow, so it will behave as if it is an open circuit. And as such, the entire current 3 ampere will start flowing through this resistor, 2 ohm resistor. So 3 ampere current is flowing in this direction, and I of t's current will start slowly to flow along this direction, right? So if you apply KVL at this in this particular loop, what will we get? First, R, if I of t current is flowing, so R into I of t plus L into di by dt, then 2 into the current flowing through this resistor, which will be equal to I of t minus 3 equal to 0, right? So at t equal to 0 plus, equation will be R into I of 0 plus L di of 0 plus by dt plus 2 into I of 0 plus minus 6 equal to 0. Now we already have I of 0 plus to be equal to 0, right? So it will be 0 plus L di 0 plus by dt plus 2 into 0 is equal to 6 if you take it that side. So di of 0 plus by dt is equal to 6 by L, which is option C. Everyone okay with this? I hope you guys are following. If you have any question, you can ask, otherwise we'll move to the next problem. Okay, then let's look at like we only had 5 problems this assignment, so we will look into few of the questions that sir has given at the end. So let us do a couple of questions from the problem sheet that sir gives at the end of his lecture. So there is a circuit given here where the different currents flowing through the 3 inductors are given as I1, I2 and I3, and one switch is there which is open, and L4 current is flowing through the inductor with inductance L. Now it is written that the switch S is open. You have to determine what is I1, I2 and I3. So can you tell me how to proceed with this problem? So let us just find first what is I. So to find what is I, what do we need? Can anyone suggest what we need to do first? Sharad, would you like to try? So we can first calculate the equivalent inductance, right? So since this switch is open, so the circuit is actually like this. So there is V connected across this. This is 6 millihenry. This is 12 millihenry. And this is another 6 millihenry. So the L equivalent of the circuit will be these two are in parallel with each other, so it will be 6 into 12 by 6 plus 12, that is 18, which is in series with this particular inductor, so it will be 6. So it is 3, 4, that is 10 millihenry, right? So the total current that will be is L into di by dt is equal to voltage for inductor, right? So since we have V given, so it will be I will be integration 1 by L V of t into dt. So this is 10 to the power minus 4 Henry, right? So 10 to the power minus 4 integration of 100 cos 1000 t dt, right? So if you just sorry, this won't be minus 4, this is minus 2 because it is 10 millihenry, right? So integration of cos theta, you know, it is what it is. Integration of cos theta, come on, are you guys following? Sharad, could you reply? So you will get the current. If you just do the simple integration, you will get total current, right? So these are small things, you can do it, right? So once you have this current, to calculate I1 and I2, you can so this particular current will flow, this will get divided into I1 and I2, and again here it will add up, that is I1 plus I2, that is the current that I is flowing through this will also flow through this 6 milliohm resistance, which is equal to I3 will be equal to I. Now I you can find out from here, right? So once you find out I, what will be I1? You see, inductance is similar to the capacitance. If two inductor are in parallel, the equivalent is equal to L1 L2 by L1 plus L2, right? So it will be similar to the resistance. So the current division will be opposite to the value of their inductance. So what will it be? If I is the total current entering it, I1 will be equal to 6 by 12 plus 6, that is 6 by 18I, that is I by 3. I2 will be 12 by 18I, that is 2 by 3I. So if you just calculate this value of I, you can calculate I1, I2, I3. I'm not solving this, you can solve it on your own, right? Can you respond like if it is okay with you?
Okay.
Okay. So we'll move to the next problem. So it is given that a 200 microfarad capacitor is charged to store this much energy by a constant current supply 100 milliamp. What will be the voltage across the capacitor? So what is the relation between energy and voltage of a capacitor? E is equal to, what is it? Energy in terms of voltage of a capacitor? Half CV square, right? So you're given energy, you're given the capacitance, you can calculate this voltage, right? So it is 90 millijoule, 10 to the power minus 3. Half C is given 200 microfarad, 10 to the power minus 6 is equal to V square. So this is 100. If we take it on the other side, V square will be equal to 90 10 to the power minus 3 by 100 into 10 to the power minus 6. So it is 9 into 10 to the power minus 3 plus 5, 900. So V is equal to square root of this, that is 30 volt, right? These are like pretty straightforward problems. I hope you guys are doing. Now this is an interesting problem. I would like you to participate in this. So find the maximum and minimum values of capacitance that can be obtained from 10 1 farad capacitor. So if 10 1 farad capacitor are given to you, like this 10 are given, what could be the maximum and minimum values of capacitance you could obtain depending on their arrangement? Can you comment on this one?
Maximum value will get if the capacitor in parallel.
Yes, because if the capacitors are all in parallel, the total capacitance will be an addition of all the capacitance, right? And it will go on. And the minimum will be when they are in series. Like this, and it goes on. So, maximum value will be equal to, in this particular case, which is 1 into 10 to the power minus 6, 10 times. So, 10. That is 10 microfarad, right? Minimum will be 1 by 10 to the minus 6 times 10. Right? So, sorry, this will be 1 by, of course. So, C equivalent will be equal to how much? See, if you take the reverse, minus 6 by 10, that is 0.1 microfarad. So, can you try for this particular problem? It is given that the switch in the circuit, this particular switch is closed at time t equal to 0. What you have to calculate is the average voltage across the inductance at t equal to 0 and the voltage across each capacitance at t equal to infinity. So initially this switch was open, no current or was like flowing through this entire circuit. So as no current was flowing through this, no voltage appeared across the capacitance. Now at an instant when the switch has just been closed, let us redraw the circuit. So this will be the circuit. Now so let us just for the time being not draw the capacitance and resistance. So this is one of it. These are the two branches. Okay. So at time t equal to 0, let us take the case A. At t equal to 0, when it has just been switched, how will the voltage, like the capacitor and the inductor be? Let us first talk about the inductor. At time t equal to 0, how will it act, the inductor?
Short circuit.
Mm. So inductor acts as a short circuit at steady state, right? When if this suppose this switch was closed and this has been running for a long time, then it will act as a short circuit. But right now
Oh,
the switch has just been closed. It will initially no current was flowing through it. this was 0. So it will oppose any change of flow of current and it will act as a open circuit. Did you follow it?
Yes, ma'am.
At t equal to infinity, it will act as a short circuit, but right now it will act as a open circuit, right? Instead, capacitor will act as a short circuit. So both the inductor will act as a open circuit. So let this be VL, VL2, VL1 and VL2. And this will act as a short circuit. This is the 2 ohm resistance, this is the 3 ohm resistance. And 10 volt is connected across it. So VL1, that is voltage across this inductor, this is the same node. This, so basically VL1 is actually this, right? VL1. Similarly, VL2 is also, this is the same node and this node are same. That is like A, B node are same, right? So this VL2 is also the voltage across this 3 ohm resistance. So so the voltage across each of the inductor will be equal to the voltage across the 3 ohm resistance, which is equal to total voltage is given as 10. So by voltage division formula, it is 3 by 2 plus 3. This comes to be 5, so 2, so it is 6 volt. So the answer to part A is 6 volt. Now at t equal to infinity, which you were talking about, then what will happen? The circuit will be, let me draw with a different color. So now the circuit will be, the inductor will act as a short circuit because at time t equal to infinity, inductor acts as a short circuit. However, the capacitor acts as a open circuit. So then it will be like this, right? And there is a resistance here, 2 ohm. So what will be the voltage across each capacitor? So if you consider VC1, you will see it is the voltage drop across this particular resistance. Similarly, VC2 is also the voltage drop across this resistance because these two nodes are the same thing, right? So VC1 and VC2 are both the voltage drop across this 3 ohm resistance. So Vc will be equal to V3 ohm. Now V3 ohm is, again, we have calculated earlier by voltage divide rule, it is 6 volt. So at time t equal to infinity, the capacitor will get each charged by a voltage of 6 volt will appear across the capacitor. Is this clear? Is this clear to you?
Yes, ma'am.
Okay. Let's look at one last problem. Initially, a capacitor is uncharged and the capacitance value is given. It is connected across a 40 milliohm constant current source. You have to find the voltage across capacitor after 5 microsecond and 10 millisecond. So can you do this? Or tell me how I should proceed? What do you need? So what is the equation of voltage and current for a capacitor? You need to find the voltage, right? V equal to 1 by C integration I dt, right? Now capacitance is given as 50 microfarad, right? And current is constant, that is 40 milliampere dt. So if you just take out, like we can take out the constant, right? 40 by 50 into 10 to the power minus 6. If you take it up, it will be 3. Integration dt is t. So initially it is given, it is uncharged. So at time t equal to minus infinity, the voltage across the capacitor is equal to 0, right? So this goes from minus infinity to plus infinity. Now for this you are given a particular current, so a particular time. So you have to find from minus infinity to a particular time t. So basically you can divide it into whatever the constant, suppose let this constant be a, it will be a into minus infinity to 0 plus 0 to infinity, 0 to t. Now this particular situation is given at 0 because initially the capacitor is uncharged. So you have to find from 0 to the particular time t. Once it is given as 5 microsecond. So it is 4 by 5 into 10 to the power 3. So it is 5 into 10 to the power minus 6 and at time t equal to 0. So if you just cancel this, it is 4 millivolt, right? Now similarly using this equation at time t equal to 10 millisecond, you can find out it is just 4 by 5 into 10 to the power 3 times, so it is 10 millisecond, 10 into 10 to the power minus 3 minus 0. So 5 to this is equal to 8 volt. So the answer is at 5 microsecond it is 4 millivolt, at 10 it is 8 volt. Is it okay?
Okay, ma'am.
Okay. So if you have this particular assignment was pretty much straightforward. So if you have any specific question regarding this, you can ask. Otherwise, we are done for the day. The basic thing to remember here is how the capacitor and inductor will behave at uh, time t equal to 0 and at t equal to infinity. That is, this one is the steady state. Also note that if it is written like the switch was initially closed and the capacitor was getting charged, that means from minus infinity to at this time 0, this circuit has reached the steady state. Now if the switch is open at time t equal to 0 instant, you have to consider that minus infinity to 0 it has reached the steady state. Now the change will happen, and sometimes it will, the question will be given such that at the time will start at time t equal to 0 and at t equal to plus infinity it will be the steady state. You just have to read the question carefully because what it is suggesting, like for in this particular case it is written as uncharged capacitor, that is when it has been closed from that instant the charging has started, there was no initial voltage. But sometimes when in different problems, like let's say, let me see, um, not this one. So like in suppose this particular problem, so initially this particular switch was closed, right? So this inductor was like up to time t equal to 0 it has been charging, so it has reached the steady state at t equal to 0 plus. Just after it, this switch is connected to B. Now the capacitor will start charging and the inductor, which has had an initial like current flowing through it, will start to this it will start to diminish and it will charge this capacitor. So you have to take into account what is asked in the question and solve accordingly, and rest of it is pretty straightforward. So If you have anything specific to ask, you can. Otherwise, we can stop the session for today. Is it okay?
Yes, ma'am.
Okay.
Okay.
Then thank you for attending. We'll meet in the next interaction session. I'll stop the recording.